need to pass user authentication data from middleware to your FastMCP tools without polluting your function parameters. You'll see how to use FastMCP's context state management to securely store user credentials and permissions in middleware, then access them cleanly in your tools, all while keeping your tool interfaces simple and focused.
From FastMCP server middleware, import middleware. Middleware context. Class user auth middleware. Middleware. Async def on call tool. Self context. Middleware context call next. Hash middleware stores user info in context state. Context, FastMCP context, set state. User ID, user 123. Context, FastMCP context, set state. Permissions, read, write. Return await call next, context. At MCP, tool. Async def secure operation data. SDR-CTX, context. SDR. Tool can access state set by middleware. User id equals CTX, get state. User ID, hash, user 123. Permissions equals CTX, get state. Permissions, hash read, write. If write not in permissions. Return, access denied. Return F processing data, for user id.
This demonstrates the middleware pattern combined with request-scoped context injection, a powerful technique for cross-cutting concerns in RPC systems. The middleware intercepts calls to provide shared services like authentication, while the context object carries request-specific state between layers. What makes this distinctive is the clean separation between infrastructure concerns in middleware and business logic in tools. The flow follows a pipeline model where middleware wraps the core handler, enriching the context before execution. The context object acts as an implicit parameter container, allowing any component in the call chain to access shared state without tight coupling. This design enables declarative security policies and eliminates the need to thread user data through every function call manually. This pattern solves the common problem of request-scope data sharing in distributed systems, particularly for authentication and authorization. It's ideal when you need to centralize security logic while keeping your business tools clean and focused. The trade-off is slightly more complex debugging due to implicit state flow, but the benefits in maintainability and separation of concerns typically outweigh this cost. Let's break it down.
From FastMCP server middleware, import middleware. Middleware context.
Imports the base classes for FastMCP middleware implementation. Middleware defines the interface for request interception, while middleware context provides access to the execution context and shared state. This is the foundation for building cross-cutting concerns like authentication.
Class user auth middleware. Middleware. Async def on call tool. Self context. Middleware context call next.
This defines a FastMCP middleware class that intercepts tool calls. The on-call tool, hook, runs before each tool execution, letting you inject shared context like authentication or logging. Middleware pattern for cross-cutting concerns.
Hash middleware stores user info in context state. Context, FastMCP context, set state. User ID, user 123. Context, FastMCP context, set state. Permissions, read, write.
This middleware injects authentication state into the execution context before tool calls. The setState method persists user identity and permissions, making them available to all downstream tools in the pipeline. This pattern centralizes auth handling, eliminating redundant checks in individual tools.
Return await call next, context.
This invokes the next middleware or tool in the chain, passing the modified context. Middleware pattern, each layer processes the request, then explicitly delegates to the next handler via call next. Without this, the pipeline would terminate prematurely.
At MCP, tool. Async def secure operation data. SDR CTX context. SDR. Tool can access state set by middleware.
This is a FastMCP tool definition. The @MCP tool decorator exposes this function to AI models, while the CTX context parameter provides access to middleware state like user permissions. All secure tools should follow this pattern to enforce access control.
Userid equals CTX get state. User ID hash user123. Permissions equals CTX get state. Permissions hash read write.
This retrieves user authentication data from the middleware context. The getState method accesses values previously set by userauth middleware, enabling permission checks before executing secure operations. This is the standard pattern for sharing cross-cutting concerns in FastMCP's middleware pipeline.
If write not in permissions. Return access denied.
This implements permission checking before executing the operation. It enforces the principle of least privilege by verifying the user has write permissions in their middleware set permissions list, preventing unauthorized access to sensitive operations. Without this check, any authenticated user could execute write operations regardless of their actual permissions.
Return F processing data for userid.
This returns the successful operation result, combining the process data with the authenticated user's ID. Demonstrates how middleware-injected context flows through to the final response, maintaining user context across the call chain. FastMCP context state pattern. The context object becomes your cross-cutting data layer, silently passing state between middleware and tools without explicit parameter chains. State keys must be strings and values must be JSON serializable, or you'll get runtime errors during context serialization. This pattern eliminates parameter bloat while making your tools more composable across different call chains.
The context that carries everything remembers nothing.